Right, good morning everyone once again. Thank you for joining us. This is the Broadcom work group in Virtual Room 5 and this session is 5AG, Automatic Detection of Performance Degradation and Analysis as part of CICD pipeline. My name is Phil Howard-Knight and I will be chairing this session. Please note that the session is being recorded and will be available via Vimeo. All registered attendees will receive an email with a link after the conference. If you have questions for the presenters, please can you submit them via the Zoom chat window using the message to everyone, and I will run through them with the presenters at the end of the session. If you have any specific points about the session or logistics, then please feel free to address them directly to me via the host only option. Please do provide feedback about the session at the end. This helps us enormously with our conference planning. Ideally do it straight after the end of the session. It can be accessed from the links on the abstract page, or you'll build your own agenda, VOAO, or by scanning the QR code on the last page of the presentation. Please note that the best score for question 1 is 5 rather than 9 as it is for all the other questions. Note also that a copy of the presentation is available for download via the conference website. So now I'd like to introduce our speakers. Ekaterina Tumanova, Kate, as she's generally known, Product Manager of CA Mainframe Application Tuner, and her colleague Petter Klomfar, Product Owner of CA Mainframe Application Tuner. Kate and Petter are both from the Mainframe DevOps division of CA Broadcom. Over to you, Kate.
Okay, thank you very much, Phil. And let me double check that everyone is seeing my screen.
That looks good to me, Kate.
Okay, perfect. So today, I'm going to be talking about the automatic detection of performance degradation and analysis as part of CICD pipelines. And today with me, I have my colleague Petter Klomfar, who will be co-presenting, and hopefully we'll see some live demonstration of this pipeline, which we created, and hopefully we will have live, but I know there are some there were some issues this morning networking around our systems, but maybe they are already resolved by the time we have a demonstration. So crossing fingers here. So just a few words about our current agenda. Let me hide this. I think you see this is a grayed out box. So just a few words about the agenda. So I will be presenting the concept, the reasons of why we suggest this approach to application performance. And we call this concept, actually, this long title of the presentation, actually, we call this concept testing performance on commit. And I will explain the solution which uses CA Mainframe Application Tuner, CAMAT as an example, and then we will go to the most interesting part where Petter will help us with a live demonstration of CI/CD pipeline powered by Zoe. I hope every one of you has already heard about Zoe. In fact, I believe I was attending GEC UK last year, and this was quite a news, the Zoe framework. So, but before we start the conversation about the proactive performance testing, about having your performance testing in the pipeline and making it part of the DevOps solutions, I think it's essential to firstly look at the state of DevOps currently. So, and we all know that there are some productivity limitations to how things were done before, and basically we all know that proficient specialists that are proficient with standard ISPF tooling with 3270 monitors are being harder and harder to find. And that's why I think that DevOps solutions are actually helping mainframe more than any other environments. And we know that some of the mainframers even prepare sometimes for retirement, and people who are hired to replace them are coming from distributed background. So they are coming from universities. They don't necessarily feel comfortable with the standard tooling. And even if we take an example of Eclipse-based IDs of the fat Eclipse clients, which some of the mainframe products have, and for example, our product, say mainframe application tuner, also has a quite a elaborate Eclipse GUI and Eclipse web client. And despite that this was a big step, and still right now by people who are coming right from the universities, according to studies, it is already considered primitive. So these newcomers who come to work on the mainframe, they prefer web IDs, they prefer web interfaces, they prefer APIs, scripting, command line interfaces. They prefer create their own scripts, their own automation, something they can really, that they can quickly adjust to their particular needs, to their new task they are working on. So that is why we are also talking about the open source tooling, and that is why we are invested into Zoe and all this open source ecosystem. And with time, actually, there is more and more teams who use open source. And nowadays, according to research, there are also modern sysprocs. So not only the modern so-called personas from developers and testers, but also there are some sysprocs who use, for example, Virtual Studio Code at their main environment where they do things, who use Git, who use other open source solutions. So, according to Gartner, actually 95% of Fortune, 99% of Fortune 500 use open source, and despite they sometimes don't know that they're even using it. So open source is actually everywhere. So that is why we are invested in this topic. So going back to our topic, to making performance testing part of these DevOps ecosystems, and making performance testing automated as part of modern continuous integration and continuous delivery pipelines. And why we think it matters. So if we take a look at the traditional approach to the mainframe application performance issue analysis. Despite that, everyone understands that the more you test, the fewer are chances that the issue will end up in production. We know from researching the market, talking to our customers, talking to other experts, that there is still quite often not enough performance testing done, and it means that the issues are actually found later. They could have been found, so they are found normally in production and pre-production environments. So if the testing is happening, it's usually a pre-production level, integration level testing, when it's hard to find out what exactly is the issue. So this leads to long and complex investigations, and for these investigations, you need SMEs, you need experts who are proficient, who know deeply the application, the environment, the the hardware, everything, so the subsystems. So these people are usually hard to find. They're quite busy. They're in demand for their time, and this creates usually a bottleneck. So, and then there is another bottleneck when these people have to communicate back to the application people, because you need to fix the issue, right? So you need to find exactly how to change the application code. and make sure that the issue is resolved. So this is another bottleneck. And right now, actually making performance testing, doing early performance testing is a big subject. It was outlined as one of key topics in the industry for 2020, and experts suggest that you actually this is not a very efficient approach. So you need to test early, you need to test often. So we suggest that you actually switch this concept to something we call test your performance on commit. So do some of the tests and some of the performance checks on every application change, on every application update. And this helps not only to detect the issues right after they actually were introduced. So you can also track the issues back to the cause of the issue easier, because you know what exactly was the code change which brought it. And according to studies, this technique can save up to 64 times on the overall cost of defect resolution when you remove all these bottlenecks and all the impact on the business of having performance issues in production. So also the modern performance products for the mainframe, they expose their functionality through the APIs, through the command line interfaces, and make it possible actually not only to detect the issue, but also to resolve it easier using standard familiar interfaces for development teams. So development teams have now a chance to actually deal with some of these issues themselves at the time of development. So according to this approach, what are the personas who would also be involved in the performance analysis now and performance issue detection? And this performance, we believe, are DevOps engineers and DevOps architects, and also modern developers and QAs who would, actually test and change the code and, deal with the issues that were found. And DevOps engineers can, using these, open APIs and open and command line interfaces and other tools that now mainframe products provide, they can include these checks into the automatic pipelines, so that to notify developers of any issues that are happening, and also to notify developers how exactly the code performs after each commit, so that they know that they take suddenly responsibility, they suddenly know that the performance of their what is exactly the performance of their code and how it changes after each commit. So this approach actually removes the bottleneck, which I mentioned before, and moreover, it allows to detect the issue early and fix it before it gets this buggy code gets deployed. And also, I think in general with this approach, when developer has some responsibility of code performance, there is actually fewer chances that the issue will be introduced in the first place, because they actually are aware of the performance of the code and take some of the responsibility for that. And so going forward, and I will be explaining what is our pipeline, what is our approach. As an example, I will use the CA Mainframe Application Tuner product. So I think it is essential before we start this conversation and go, technical, actually understand what this product is and what it is used for. So just a very brief overview. So we support currently So first of all, say mainframe application tuner, and as we call it, CMAT, quickly, it is one of the mainframe products on the market for which targets application performance, and specifically not the system performance, but application performance. And it is mainly used for performance issue analysis. It is also used for performance application performance optimization, and it's used also for proactive monitoring in production and pre-production of the applications and its performance. So meaning, identifying issues before they occur. And we support a large number of subsystems, over 20 subsystems, and a long list of languages, including, of course, COBOL, PL1, assembler. We have extensive support of Java. Actually, last year there was a huge update and a new Java agent, which supports basically all possible ways you can run Java on mainframe. And also, which is important for our conversation, it includes this automation component, which is called PMA, Performance Management Assistant. And it basically helps you to be proactive. As I said, right now, it's mainly used in pre-production and production to learn application under test and predict that something is about to happen. It also, so speaking of how we do it, so speaking of the analysis, just a few words, and it depends from product to product which sampling mechanism you use. Each product uses, and we, for example, use some non-intrusive technique using DIA routine. It's we kind of look at the application from above. We know what exactly, we don't stop the application, we just look at what is executing at the CPU at this particular time. So this gives us insight, and then we aggregate this data, we show this data in our analysis and targeted analysis views for each particular application. So why I'm speaking about it is because we will show also how exactly we expose this analysis, how it can be used by development teams in the pipeline. We have a large number of integrations with other products, but that's not the point of this conversation. I think what is the point of this conversation is how you take such product or another product that you have and how you leverage it in a modern way using open source tools, using the modern techniques, DevOps techniques and agile pipelines to actually be more effective and find issues earlier. So what are the ways to be proactive to application performance? And as I said, unfortunately, a lot of customers are still in this top right box. So I'm explaining this slide kind of in reverse order. So we go from the top right where we have the issue analysis after the fact. And unfortunately, as I said, a large number of customers are still, just analyzing issues after the fact. And for that reason, of course, all the products and MAT as well provides a wide range of tools for you to find out what is the cause of the issue, what is happening, give you a deep insight into the problem. And then another level is being proactive in production. So you can have an active application performance monitor, not just system monitor, but the application performance monitor, which would learn the application under test and let you know, alert you whenever application starts to misbehave, and you can look and address the issue before the impact actually grows. Still, it may be too late, and still sometimes the investigation of the problem can be so complex, and you spend a lot of time, and still, if it is an application problem, if it is problem with application access, how the way application accesses the database, for example, you still need to communicate with development teams and spend a lot of time on this process, do the rollbacks, and so on. The most modern approach, and the approach in which we believe is being proactive in development and test at least have some subset of tests performed on each application change, or at least to have an active monitoring of while you're executing, for example, your functional test bucket. You can just monitor how your application behaves. And for that reason, we actually use the same product, the same component, PMA, but for monitoring on the testing system, but we provide different different access, different APIs, different way to access this data, and this changes the whole user experience, and we will show how exactly. And just to get a little bit closer to our further demonstration, I would like to explain how exactly we suggest you do it using product like MAT, product enabled for the with the command line interfaces, or product that is participating in a Zoe ecosystem. So when it comes to application performance, as I said, we introduced a concept of performance on commit, and we introduced it using and providing two new Zoe CLI extensions. These are Zoe conformant plugins. We received conformance right after the publishing, and we are continuing to stay conformant and update these. And when we speak about these plugins, they both target kind of different personas. So the first plugin, which is called CMAT Detect, it targets DevOps engineers and CICD architects like Ravi here on the left, and it allows them to, not simply just have a pipeline for functional testing, but also include a check of the application performance right into the pipeline. And whenever the application shows a misbehavior, whenever the underlying component that is gathering this data, the underlying component for MAT will alert Ravi using this command line interface, can extract the alerts, the basic information, the basic performance metrics, and immediately notify the development teams. So that is the purpose of CMAT Detect. If we talk about CMAT Analyze, it targets, we call these teams of Michelle. So Michelle is our persona for modern developer, modern QA, who would actually receive this notification that some performance issue happened after the recent change. And CMAT Analyze is then used after the fact the issue was detected to actually look deeply at the application performance. So this is where actually the sampling component of CMAT is used, and we expose it again through Zoe, through CMAT Analyze. And now Michelle, working in her for the IDE of choice, for example, Visual Studio Code for Z, how we call it with extensions, and she can receive an email notification that there is a problem. She can receive the basic performance metrics through the email. She can also immediately start researching using CMAT Analyze, doing sampling analysis, and immediately start researching the issue. And the beauty of this solution is that two plugins actually work together. So Michelle doesn't need to rerun the test and sample again during the reproduce test, she can already start analyzing the issue because these two plugins work together, and detect already have sampled the application and already has created data for analyze. So she has data from the time the issue occurred. And at this point, I would like to switch and to give Peter a chance to show us, hopefully live, but depends on how our networking is behaving today, the actual demonstration. And we tried to build this case based on, imagine that you haven't introduced the issue. How would this pipeline work? How it will all look like? How it helps you to find out that you introduced it, and how it helps you to actually fix the issue. So, Peter, now it's all yours.
Thank you, Kate, for handing over. Can you hear me?
Yes, loud and clear.
Alrighty. So let me just pop into the presentation, start from the beginning. Good day to everybody who's on the call. It's an absolute pleasure to have you here. Once again, thanks, Kate, for handing over to me. I will try to walk you through the diagram in our implementation of performance on commit, and as Kate was describing just a minute ago. So the high-level diagram before we jump to the live demo is following. Michelle, the modern developer, as you heard, will update the code within the ID of her choice, and I will be using Visual Studio Code for the presentation. She will save the change, stage the change, commit it to her GitHub repository, and she will push it through from GitHub to the backend, to the mainframe, to our source code manager, which is Endeavor. It will be carried over through a solution called Enterprise Git Bridge. And the code change will be reflected within the elements of source code manager on the mainframe, where we have a webhook server set up to listen to an actions. These actions can be pretty much any. We have it set up for update action, but it can be generated in place. It can be moved from dev stage to QA stage, or even to the production. It's really up to you how you would decide to set up your DevOps CI/CD pipeline. Whenever the webhook listens and registers the update action, in our case, our CI/CD pipeline is being triggered. Our CI/CD pipeline is being orchestrated by Jenkins in our case, and already at this stage, CMAT detect component kicks in. It's being backed up by Performance Management Assistant, as Kate said before, and Michelle would be able already at this stage utilize some CLI commands such as get performance or get alerts, which will fetch the information from PMA clusters, vSAM clusters, and provide some basic information. But since we have it in the pipeline and we want to have it more, user-friendly for her, we are providing automated email reports. So whenever the performance is being judged, all the commands are happening in the background, and she receives performance report. Whenever a dreadful situation or performance degradation happens, she would receive an alert type of an email. In that case, our CMAT analyze component, backed up by CA mainframe application tuner itself, would kick in and perform automated measurement of the job under test. And the email would come in a similar manner like this. I will show you live throughout my email client. So let's just glance through it. And at this stage, Michelle most likely was to drill deep and dig deeper and understand what's the root cause, what's the culprit of the performance degradation that she is being reported throughout our performance of commit functionality, excuse me. So at this stage, she would typically, within her Visual Studio Code, she would utilize some of the Zoe commands that we can provide. And I will show you, it will be even neatly shown to her within the email itself, so she doesn't need to remember anything. And she can utilize them within the terminal, and she can display, for example, the overview or the history runs of the measurement, or even drill down to the code section and up to the statement level. And I will try to show you live in a second. So this would be it for the, preface with the diagram. And now let's go to the live demo. So I will take a role of a Michelle, of the modern developer, and within my Visual Studio Code, I have my repository linked in and downloaded, and I'm showing currently a demo COBOL program. It's a simplified program for installation verification purposes of our product, and we are using it just for the simplified demonstration at this stage. But bear in mind that Michelle can be coding anything within her application, coding a new functionality, checking some lines, changing, tweaking. She can be trying to resolve a customer defect within the application that she wants to have a performance reports on. On behalf of Michelle, I will just conduct a small change within this, for example, line for the perform. I will just ramp up the numbers. For us, it's just a simplified scenario. And as I said before, typically I would save it, then I would go to the branch, I would stage it, and whenever I would stage it, I would commit it into my GitHub repository. From this stage, let me let me take a look on my mainframe. I'm still waiting for the response for just barely a change of a panel. So unfortunately, I won't be able to show you exactly live, but it will be semi-live, and I'm prepared with the backup for that. So when I would be committing the change into my GitHub repository with a specific node, it would bring me basically here. So in my GitHub repo, I would probably see the latest CCID or latest name of the change that I have been committing. Mine is 18 hours ago because, again, due to the networking issues, I cannot do it at the moment live. Respectively, commit to the Git, I definitely can, but the overall pipeline kickoff would for sure fail because we cannot communicate with the mainframe at the very moment. So the workflow is that from ID of my choice, I made a change. It's coming to the GitHub repository. From the GitHub repository, it's being pushed through to my mapped source code manager environment, which is development environment for my product through the C Endeavor bridge for Git. And if I may just move it on a side. Then, as I said, we would have a webhook server listening to any actions. In our case, it would be an element picker for Endeavor, and it's set up for update action. And as you can see, I have it on. And that would have a effect of triggering the pipeline. Let me very quickly back up to my presentation. And this is what you would be seeing live if the network would be cooperating with me today. We would see shortly the kickoff of the pending pipeline. A new pipeline would be triggered, and you would see processes through the stages as you are used to for your automation framework for Jenkins, for example. Then I would switch to Blue Ocean, where I simply like the presentation of the stages a little bit more. And we would see it finalize and execute. For that, I can switch back to the actual Jenkins, and I can click on it, and I can do Open Blue Ocean, and I can walk you through how the pipeline is being orchestrated at the very back or on the background. So we would start with the Autogen Compilation Job because we want to have the results consistent. So we would generate the job within the source code manager, and we would submit it for mainframe processing. So utilizing the Zoe commands for ZOS job submit for this specific data set, we would first generate it. And then we would move to the step where we would submit the job itself. So the job itself would be submitted in the similar manner. And then PMA kicks in, or CMET detect component kicks in, and we are really pulling the results from our KSDS clusters for job and for alerting based on the situation that is being observed by the automated pipeline. And at the end, in the last step, check for CMET monitoring profile. Whenever the dreadful situation, as I said, would happen, our CMET analyze component would be kicked off, and our measurement of the job under test would become live, and we would basically download all the necessities of the information and construct the specific email report. At this stage, when the CI/CD pipeline would finish, Michelle would receive the specific email report as I was talking before. It has multiple stages. For every execution in the beginning, we need to set up the initial baseline for the calculation. So first 3 runs, we are basically learning the application, or PMA is learning the application in the background. And after that, she will most likely receive the email saying within the normal range. That's where everything, plays colors, and we have a bright blue skies, no deviations, no performance mishaps are happening at this stage, and is the regular run as she would be expecting. We already have the average for the baseline calculated, so she will be presented with the email with 4 specific tiles. Those KPIs for CPU deviation, elapsed deviation, XCPs or IOs if you wish, or service units are representing the deviations from the average values. And she would be also receiving a short summary within the email itself, stating which job we have measured, what the step name or program JCL, what we have been providing for an execution as a summary. And she would see the average baseline calculations, as you can see for the KPI matrices. She would see the exact metrics outcomes for the current run that she just submitted throughout the pipeline, and she would see a direct comparison with the previous run that happened in the past execution of the pipeline. But we will focus on the scenario where the dreadful situation of the performance degradation would happen. So whenever she made a code change and ran this pipeline again, she might receive an overall status of an alert. Again, this is where the CMET analyze at the background already done the measurement, so we can dig deeper right after this performance report. And as you can see, the tiles are not that nice anymore. We are seeing significant percentage increases within CPU deviation, service units, as well as elapsed times. And within this specific email, we also provide a Zoe commands. This is where Michelle can easily correlate and dig deeper and taking the Zoe commands from the email without need of her, studying the documentation or even, remembering any of these. By running this several times, she will likely remember, and she will have them within her terminal anyways, but we provide this for her convenience. That would bring me back into my Visual Studio Code, into my terminal. And let me try it if the system has come alive. So first start with the overview. Otherwise, then I will refer to a screenshots again. As you can see, just starting from the high-level math monitor overview for this specific demo profile, I'm still waiting for the response, and just not to hinder the performance of this presentation, allow me to digress back to my screenshots. So let me just switch here. You should see the presentation again. And if I switch to my slide deck in regards of the commands, whenever she digs deeper, she can do it in multiple ways. She can either bring up the monitoring results from the most latest run, or we provide a command, Zoe Math Monitor history for the specific profile, which will allow her to investigate the previous runs that she would have measured for this specific application. In that case, the overview command that I just tried to show you live in the Visual Studio Code would, instead of the -- profile for this demo CICD, would refer to a monitor number that we would acquire from the Zoe Math Monitor history. For example, monitor number 8 would bring up this 2020 yesterday's measurement at 154. After that, she gets the overview of the measurement, where she gets the high-level understanding what same mainframe application tuner have seen, where the data were stored under what monitor dataset name. Also in our CMET database, she would understand what information were collected about the environmental, knowing, for example, which DB2 level was involved. And so in our case, it's just a batch application for COBOL, so there is not much to be seen here. And within the report for overview, she would also see activities of how many samples we basically used and how many active samples were measured for this application and how many wait samples. Because CMET itself can provide multiple contextual informations based on what is your most need or what is your most interest. We can either focus on, for example, code view to get knowing where most of the activity on the heavy hitters were displayed, and tune it from that perspective. Or for some occasions, you might be interested to actually see delay view and see what were the weights allocated, the delays for a specific application. So when we take a look on the code view itself, we have another command that would say Zoe mat monitor code view for CSEC of this profile. That would bring you the output of our code view. And in the code view itself, you would clearly see that our democob B1 or democob 1 application was the heaviest hitter here. It was responsible for 22% of the activity and 58% of the weights in general throughout the application execution. And whenever we would dig even deeper up to the statement of the level, you can use the mat monitor code view histogram for this specific profile, specifying this specific module and CSEC. And I'm sorting it by top 20, which will automatically sort it by the highest activity at the top. You would see that our code section democo B1 and statement 141, which was at statement, was the heaviest hitter here. It was overall from the democo B1 responsible for more than 18% of the activity. And within the Visual Studio Code, I can easily, from a terminal response, correlate it back into my editor. And I can see on the statement 141 that this is the instruction, including the at, that was responsible for the change. And I can see it's part of the subscript 2 minus 100 label. And that leads me back or pigtails back into the line 101, where I just confirmed the change that I was trying to do live. And let me just get back here. Respectively, we offer even more. As I said, multiple contextual informations. So we are constantly evolving within the Zoe responses and our RESTful APIs. So you can expect more and more, but at this stage, you can also display the delay view, as I said before, for example, from the perspective of most weights. And whenever you would do Zoe mat monitor delay views for this specific profile for program active and program activity, you would see that again, Democo B1 on 9 Alpha Echo is responsible for one of the highest hitters. If you would bring up the listing, that would bring us exactly back to the COBOL statement, respectively to the assembler instruction within a COBOL statement, because for COBOL, multiple assembler instructions state or correlate to one statement, and it would lead us back to the add instructions as well. But we can provide at this very moment even more items. For example, caller ID. It's very important for performance tuning to understand what is calling your product and what are the webs behind, to understand basically the behavior at the background of the application. And again, you could utilize Zoe mat monitor code view CSEC for this profile. You can inspect the column which would say C and Y, meaning that we have a caller ID information for that one. And just for example, I have picked the IGZ CPEC module and CSEC. So if I would drill deeper with the REST API endpoint and Zoe CLI counterpart with this module in the CSEC, I would receive the caller ID information, which would lead me to statement 152 and 161. And again, very easily, naturally, I can correlate it within my editor of choice, in my case, Visual Studio Code. And I can see that this inspect on 161 and 152 were the parts where we have been calling, respectively, where this system routine was called within our application. That basically brings me back to my slide deck. It is very important for us, if you would have any feedback and thoughts, just share it with us. We are very open, and on the screen you can see Kate's contact information as our product manager, my contact information as product owner, and we also have a very great architect of our product, which is Tofik, and you can contact him as well for any technical related information. In order to make it easier for the consumers itself, we also have introduced something which we call CICD pipeline performance on commit guide. This is a open, extrapolated or external tech documentation where you could learn easily how to install this performance on commit functionality using CMAT and PMA, but it will also provide information how to approach basically the DevOps pipeline creation. So it is very interesting document, and I really suggest you to go through if you would have a chance. And also, Kate said it before, our conformant plugins are easily downloaded from the npm.js site. And let me very quickly just demonstrate. On npm.js site, if you would filter for @Broadcom, you would see all the plugins listed. And if I just drill down for CMET, you can simply download it to your convenience into your terminal, bash, or Zoe CLI and start using them. Let me just take us back. And that basically brings me to the very ending of this presentation from my side. I will be happy to answer any questions shortly. But as Phil has pledged in the beginning, really, submit your session feedback. We would be really happy to see and hear. You can either use the QR code, which you see on the screen, or you have in your downloaded materials, or just going throughout the URL at the top. This session specifically is 5AG, just a reminder. And as one more reminder at the end, GSE traditionally is running a charity, right? So consider yourself showing an appreciation and kindly donating a small sum to GSE charity this year. Again, you can do it through the obtain the information through the QR code in the bottom or following the URL link within your materials. And with that, thanks from my side. I will stop sharing and I will be happy with Kate to answer any questions you might have in regards of this presentation.
Well, thank you very much, Peter and Kate. A very interesting presentation. And thank you, Peter, for doing part of my job for me. That's excellent. So reminding people to fill in the session feedback. Also, if you wish, if you have it in your BYOA, there's a link at the bottom of each agenda item to go take you directly to the feedback. So that's the third way of doing it. So does anyone have any questions? Please do put them through now on the chat window. I haven't seen any come through as yet, but I shall wait for a minute to see if any more do. I know the chat window is working because I have chatted with a couple of the attendees during the session. So. Sorry, Kate, I hadn't noticed you were muted.
No problem.
Maybe just to highlight, even though if you wouldn't have the question at the very moment, again, I encourage you to, reach out to us because we will be very happy to engage in discussions and perhaps even share your experience with the performance tuning and CICD integrations in any ways. So it will be a mutual learning experience for you and us as well.
Yeah, I would like to emphasize that, we realize that not everyone on this call is actually a math customer, but this topic is so emerging and so interesting of identifying issues early in a life cycle. Even if we don't talk about the performance testing, just shifting the testing left, and we would be happy just to have a conversation. If you're a practitioner of DevOps, if you're a performance analyst, if feel free to reach out. We really would like to actually learn from your experience as well, and find out what would be useful in your case. And yeah, I would like to actually, if you happen to still be on the call, to ask you if you feel like this is something that you could use, this concept, this kind of pipeline in your shop. If you feel that this is something useful, please just type in the chat. I'd like to hear from you.
They're a quiet bunch. They have been all morning, actually. I've not had many questions while I've been sharing. I don't think it's me.
Don't be shy.
Yes, please don't be shy. Anyway, as both speakers have said, you can contact them after this session via their email addresses. So I will wrap things up shortly. Unfortunately, this being a virtual event and everybody being on mute, no, we can't give you the normal round of applause, but I will anyway. Thank you very much to both of you. And, thank you all those who came for attending, and I hope you enjoy the rest of the conference. And with that, I will end the session. Thank you very much again, Kate and Peter. Oh,
thank you so much.
A hand clap from Mr. Thyssen as well. Thank you very much.
Thank you so much. Okay.
Bye-bye.